Alright class, the last thing we're going to learn is cross products. So when we did dot products we got a number, but when we do a cross product we get a vector that is orthogonal to both of the vectors that you're crossing. Okay, so to do a cross product, I do it a little differently than some people. It's very similar though. You have to, it's like taking the determinant of the unit vectors I, j, k, and then you list the numbers for v, which are 1, 2, and 3, and then you list the numbers for w, which are 4, 5, 6. To take a determinant by hand, what I do is I repeat and expand right next to the determinant the first two columns. So I would write an I here, a 1, a 4, and a j, a 2, and a 5. So I'm going to just write that down here. Repeat columns 1 and 2. Then it's going to be the downs minus the 3 downs minus the 3 ups. And what that means is, if you remember when it's a 2 by 2, like A, B, C, D, when we did these before, you would do AD minus CB. It's the same thing except for you have 3 of them and then you have the answer. So if I'm going to do this, I'll do it with a highlighter to show you. So the downs start in the upper right hand corner. That's 1, 2, 3. And the ups will be in the light blue. 1, 2, 3. This will just help me visualize what I'm doing. So V cross W then is equal to 12I plus 12J plus 5K minus parentheses, because you have to minus all of them, 8K plus 15I plus 6J. Then you distribute your negative sign and add your like terms. So the i's are 12 minus 15. So we get negative 3i. 12j minus 6j, I'm sorry, yeah, is 6j. 5k minus 8k is minus 3k. And there's our cross product. Okay. So let's do another one. But that vector that we just found should be orthogonal to both. Later on we'll test that theory out. Actually, let's test it now. I'm going to call this vector A. To test if they're now orthogonal, you do the dot product. So v dot a, so I'm going to take my answer, negative 3, and dot it with v. That's times 1, plus 2 times 6, plus 3 times negative 3. So if I do that, I get negative 3 plus 12 minus 9. Sure enough, that equals 0, which means a and v are orthogonal, and you can check it again to see w. Okay. Alright, the next one. A cross B. Be careful though with these. Notice how this has an I, a J, a K, this has an I and a J. If there's no K there, put 0K. There's a 0. So we have the determinant of I, J, K. 5, 2, 3. Negative 2, 5, 0. And then you do the I and J column again. So 5, 2, negative 2, 5. Now we do 3 downs minus the 3 ups. So I get it's equal to 0I. I'll just put that down. Minus 6J plus 25K minus parentheses negative 4K plus 15I plus 0J. Okay. So we have that. So the answer is 0 minus 15, so negative 15 in the I direction. Negative 6 minus 0 is negative 6 in the J direction. And 25 plus 4 is plus 29 in the K direction. There's your cross product. Okay. Next one is the last one. Why don't you guys pause and try it on your own. See if you can do it. Notice how this one's missing an I, so I'm going to say it's 0I plus 1J and plus 1K. Remember, when there's a no number there, but the K is there, it's a 1. So P cross R. is equal to ijk. 5, 3, 1, and 0, 1, 2. Taking the determinant of that, which means we have to expand the first two columns. Okay. Now I do my downs minus my ups. Alright, so we get 6i plus 0j plus 5k minus 0k plus 1i plus 10j. So we distribute the negative. 6i minus 1i is equal to 5i. 0j minus 10 is a minus 10j. 5k minus 0k is a positive 5k. And again, you can take the dot product of this with either of those and show that they are equal to 0. Okay, so that is what a cross product is getting us a vector that is orthogonal to both of the vectors that we crossed. And that is it. I hope you enjoyed it. I will talk to you later.